name is Federico Tenga. I'm co-founder of Chainside, an Italian company where we help enterprises to accept Bitcoin payments, providing services and software. And I'm also advisor for the Italian government to work on a national strategy for blockchain. So what we're going to talk about today is about the sustainability of a multi-blockchain ecosystem. And the goal of this presentation is first to challenge the hypothesis that multiple blockchain competing between each other can coexist in the long term and it is a sustainable model. And then we will analyze an alternative model with a single chain but working on multiple layers. So what is the multi-blockchain and multi-coin hypothesis? It's the idea that it's pretty much the situation in which we are right now with the crypto ecosystem, where we have multiple blockchain that serve with different purposes. So for example, we have Bitcoin for payments, Ethereum for decentralized application, and some privacy coin for people that need more privacy. And all these different blockchains, they kind of coexist between each other, and users move between one and another depending on the application they need. But there are some problems with this system, and now we are going to analyze three main problems why this may not be actually a sustainable model in the long term. So, first problem, a multi-coin wallet is usually insecure. Why? You may have something like Jax or many other wallets that may provide a very good user experience. You have on a single wallet multiple coins that you can transfer easily. But there is a problem with this kind of wallets that they usually don't talk directly with all the blockchain that they need to move the coins that are stored in the wallet. But they usually just talk with a third-party servers that provides them information on whether they have received a payment or not. So this is, for something, blockchain is supposed to be something that eliminates trust, the need of trust towards third party. So reintroducing trust towards a third party to monitor incoming payments is it's not ideal, because there are many problems that could emerge. It's not only about the third party, but you also need to, if you don't fully audit all the blockchains that you're using, also the miners could scam you in some way or attack you and eventually maybe even steal your money or in some different ways. So this is not a very secure model. So if you really want something that is trustless, which is probably the reason why people use cryptocurrencies, this model is not able to provide it. But this is not just a bad design from wallet providers, because actually talking with all the blockchain, all the many different blockchains simultaneously is very difficult, in particular because it is very expensive. So if you want to audit a single blockchain, you already need some resources in terms of storage, internet connection, and CPU power, because you have to validate a lot of data. And if you have to do it with many blockchains, it is likely that the laptop or the hardware that you're using, that is maybe just a consumer-grade laptop, is not an enterprise server, is not going to be able to handle that. So that's why most multi-currency wallet use the model that we've seen before, because it is unfeasible for normal hardware to audit all those different blockchains. So this is the first problem, that it is difficult for a user to handle multiple blockchains. The second problem is related more on the monetary aspect. And before talking about this, let's see why we have let's first have a look on why we have money in the first place. So money was invented, or discovered, depends how you see it, mostly because it makes markets more scalable and more liquid. So to see it in very practical terms, on the left, we have the example of a market without money, where people are still using barter. And in this market, so each good is traded, can be traded against all other goods directly. And so the number of prices that a trader has to keep track of in this market is almost the square of the number of items present of the goods present in the market. Which now in this example we just have 4 goods, but in a normal modern market with millions of goods, this becomes very difficult to handle. And also the liquidity is split between all those different pairs, so each individual pair will probably be very illiquid, at least most of them. But if we introduce money, so if we start using one of those goods as an intermediary commodity to trade everything else, in this example gold, which is what was used for a good portion of human history, then things becomes much more scalable. So the number of prices that a trader in the market have to keep track of is linear with the number of goods. And also all the liquidity that is in the market is more concentrated in fewer pairs, so each pair will be much more liquid and the market is much more efficient. So this is the utility of money, to provide more scalability and more liquidity. And the utility of money is maximized when we have only one form of money, because if we have multiple forms of money, we can lose this advantage that we just gained. And this is the problem with multiple cryptocurrencies. So if I have multiple cryptocurrency for different purposes, so for example, I have the privacy coin, the fast transaction coin, the store value coins, the decentralized application coins for all those kind of different use cases that a user may need, then I go back to the original problem that I have to keep track of many different prices and the liquidity is split on more pairs, so the markets become less efficient, more illiquid. And the problem is with blockchains, either they are proof of work or proof of stake, you need a native token for security reasons to compensate to pay for the security of the blockchain. So for miners, if for proof of work blockchain, you need a native coin to pay miners, for proof of stake to provide something to put a stake to make sure that to create the right incentives to keep the blockchain secure. So this is the second problem. Multiple currencies are not very good from a user experience and from a liquidity point of view, but multiple blockchains require multiple currencies. Then, third problem, the performance security trade-off. Okay, so every system has to deal basically with this trade-off, security versus performance. So right now, if you want something that performs very well, can handle a lot of data and has a lot of flexibility, a lot of features, the extreme, the best system you can have is something like cloud computing, so something like Amazon Web Services, where they can provide very good performances for whatever is your application, and of course also for monetary applications. And at the other end of the spectrum, if you want something that is super secure and as trustless as possible and resistant to censorship attempts, today you have Bitcoin, which is pretty much the best that you can have on this side, which sacrifices performances to get all of this stuff. And if you use cryptocurrency, probably you use both of them. You use Bitcoin when you do on-chain transactions with Bitcoin, and you use something like Amazon Web Services when you use an exchange. So exchange use cloud computing to keep track of the internal accounting of balances. Then all the other blockchains try to go somewhere in the middle. So, for example, you have Ripple that has much better performances than Bitcoin, but is more centralized, so it has less security. Then you have Ethereum that is something in the middle, and others now. This is just an approximation, so people may have different opinions on where to put the different coins, but more or less the problem is that you can see that it quickly become very crowded, the space in the middle. So you have multiple blockchains with slightly different trade-offs that compete for the same users, and they sort of cannibalize themselves, because users are those that provide the resources to keep the chain secure, so the wealth that back the security of the blockchain, whether it is proof of work or proof of stake. And if the space in the middle is too crowded, then it is unlikely that all of them will be able to be sustainable with a good security model, because they're competing for the same resources. And this is a problem that does not affect if you are if you are on the extreme of the spectrum, either on the left or on the right side. Because if you want security and it's your priority, you have to go on Bitcoin. If you want performances and it's your priority, you have to go on cloud computing. But for all of those that are in the middle, it's more difficult to provide a long-term value proposition. And again, if they are competing for the same resources, it's not sustainable to have many of them staying alive for the long term. But let's see what is the source of this problem, the choice between, the trade-off between security and performance. The source of the problem is this impossible triangle. So in any system, you can have consensus, decentralization, and performance. With consensus, we mean that every user converges on the same state of the system, so there is no split on the ledger. Performance is the ability to handle the demands of competing system. So, for example, if you're a payment system, you should be able to handle the same demand that Visa or MasterCard or PayPal are able to handle. And decentralized, that there is no single point of failure. And unfortunately, you have to pick two. You cannot have all of three together, because there are some fundamental problems, especially between performance and decentralization, because you either have one if you want consensus. So with a blockchain, you usually stay on the consensus decentralized part. For example, Bitcoin, you have consensus because every user have the same, can converge on the state of the ledger. You have decentralization because there is no single point of failure, but you have very poor performances. So the solution to have, somebody may want a different trade-off level, may want a little bit more performances, but less decentralization or something like that. And a solution to achieve different trade-off levels for different applications is to introduce layers. So we have a blockchain layers that is very secure and achieve consensus. And then you have upper layers that may either have consensus and performances, but be quite centralized, or have performances and decentralization, but do not require consensus. So not all the users have to converge on the same state of the ledger. And here we can see some example. So this is how it works, some example of layers on Bitcoin right now. On the base layer, we have just the Bitcoin blockchain, which is reasonably stable and quite secure. Then on the upper layers, we have, for example, Lightning Network, which is a protocol to have a quick transaction on Bitcoin that has good performance, has decentralization because there is no single point of failure, but doesn't have consensus because not all users do not have to know every transaction that happened on the Lightning Network. They just know the transaction that somehow they are interested in. And another example is Liquid, is a sidechain developed by Blockstream that still has consensus because it still has a structure that is similar to a blockchain. Has better performances, but is quite centralized because it has a federation of validators. So you can have, and on top of that, you can have something like third layer protocols. An example is RGB, which is a protocol to handle tokens on top of Bitcoin, which could work both on top of Lightning Network and Liquid. So the idea is we have this blockchain layer, which is what we all use, we all audit. And then we have upper layers for different applications. So Lightning Network and Liquid, they are both trying to achieve a and higher transaction throughput than Bitcoin, but there are other examples of possible second layer application, like older color coin protocols, like Counterparty can be considered second layer application, or many others. So the idea is we have second layers to handle complexity and to have different trade-offs than what we can have on the base blockchain layer. But the base layer is very solid, is something that is secure, is not cannot handle like a lot of data, so it's not doesn't have a good performances. But those kind of stuff, it's work on the upper layers. So how do we have to work on the layer approach? So the base idea is that the base layer is to stay as light and as stable as possible, so everybody is able to audit it. It doesn't require a lot of resources to audit the base layer, so there is a lot of security because everybody can audit it, and is stable because if it's light, many people can participate in the network, and it is unlikely that there are splits or other events that may disrupt the continuity of the network. The second important rule is to keep as much complexity as possible in the upper layers. So if you want to build like some weird application that requires some more resources for the user, or some more complex algorithm to be used, use it on the upper layer, so if something goes wrong, you don't disrupt the base layer for everyone. And last but not least, to keep things modular, so users only have to handle the data of the application they are using. So, for example, Lightning Network users don't need to know anything about what's happening on the Liquid sidechain, and people on the Liquid sidechain don't have to handle all the complexity of the Lightning Network. So, if you keep things modular, it is much easier to scale a system. So, a few conclusions. An ecosystem with several competing blockchain fighting for resources is not expected to be sustainable in the long term, for the reason we have seen today. Multi-layer approach can achieve the multiple trade-off levels that it's what the multiple blockchain actually are for. You have multiple blockchain because you want different trade-off levels for different applications. You can achieve the same with multiple layers. It may be a little bit more difficult. There is still a lot of research and work that has to be done on this side, but this is a way to approach this problem. And again, it's a must to keep the base layer, so in the example that we've seen before, the Bitcoin blockchain, as light as possible, so the decentralization, the security of the system is ensured. So that was the end of my presentation. Спасибо.